Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Afiq Hamizan bin Syarudin. I am from BMMH 1/2. So today I want to tell you about how the HVAC works. So there are 4 basic components for refrigerant system. First is evaporator, second is condenser, compressor, and metering device or expansion valve. From evaporator, low temperature, low pressure refrigerant enter compressor. A liquid at high pressure is needed to achieve refrigerant effects. Refrigerant at high pressure and temperature, but in a gas state. Move to condenser. Heat from refrigerant is transferred. The cooling fluid refrigerant condensed to liquid. For hotter liquid, refrigerant has high temperature and high pressure but lost pressure when go through expansion valve. So some vaporize and absorb heat from refrigerant. That does not vaporize. It's called cooling effect. In expansion valve, pressure has been reduced, dissipating heat, cooler than fan flowing around. In evaporator coil, refrigerant absorb heat from warm air and reach low boiling point. Refrigerant vaporize and absorb maximum heat. So there are 5 compressor types that I want to tell you. First is reciprocating, rotary, scroll, screw, and centrifugal. In reciprocating, advantage of reciprocating is initially cost installing is typically low. Second, able to provide continuous flow. And disadvantage of reciprocating is first, highly maintenance cost because of many moving parts. Second, reciprocating cause vibration. For rotary compressor, advantage is they can deliver liquid to high pressure. Second, less vibration. Third is low leakage level. Disadvantage of firstly most expensive than centrifugal pump. Second, short lifetime and not suitable in dirty environment. Okay, for scroll compressor, first, it reduce energy cost. Second, gas pollution also minimized. Disadvantage of this scroll compressor, they are not easy to repair because of cannot be disassembled. Second, increment capacity control. On system with several scroll compressor has proven several times of problem as well. As for screw compressor, advantage is highly specific output, and second, less moving part. Disadvantage of screw compressor is first, debris is produced. Second, bearing problems. So last but not least, centrifugal compressor. The advantage of centrifugal compressor is first, highly reliability. Second is install cost is lower due to small size. Third, low maintenance cost. And lastly, no loop or oil contamination. Disadvantage of this centrifugal compressor: first is low efficiency, second is very sensitive, lastly no effective for low molecular weight gas.
Hi everyone, my name is Muhammad Zahim bin Muhammad Sukairi. I'm from University Technical Melaka. Today I want to walk through about condenser. What is condenser? Condenser is a system that extracts heat from the cooling gas that is absorbed from the evaporator. The refrigerator gas heat will flow through the condenser walls to the medium condenser. The gas in the refrigerator is cooled and diluted, thereby becoming liquid. There is three types of condenser. Number one is air-cooled. Air-cooled is fin condenser natural air convection and fin condenser forced air convection. Number two is water-cooled. Water-cooled has shell and tube, shell and coil, and tube in tube. Number three is evaporative. For the next slide, I will explain you about air-cooled condenser. Air-cooled condenser is a coil circulates through the refrigerant and air flows through the outside of the tubing. It has air motion caused by natural effect of natural convection when air is heated. Air condenser typically installed outdoor. For the operation, this is the condenser in which the removal of heat is done by air. These condensers are the most popular type used on small commercial and domestic refrigeration and air conditioner unit. They consist of steel or copper tubing through which the refrigerant flow. The tubes are usually provided with plate fins to increase the surface area for heat transfer. For air-cooled condenser advantages, air-cooled condenser used in location where water is difficult to use. It has very simple construction. It has low initial cost and maintenance cost. It has less piping work to do. It has less chances of falling. And it has very easy to clean. For disadvantages, air-cooled condenser used in location where water is difficult to use. It has very simple construction, low initial cost and maintenance costs, less piping works to do, less chances of falling, and it is very easy to clean. For disadvantages, air-cooled condenser has less specific heat capacity of air. Large flow rate of air is required. Low thermal conductivity, small heat transfer coefficient of air, and lastly, less coefficient of performance. Next, I will walk through about water-cooled condenser. The design of shells and tube is usually used in water-cooled condenser. When available, water from reservoirs, rivers, or wells is often used. If there is insufficient natural water as sources, water must be recirculated through the cooling tower to refrigerate it. For the operation, the condenser is the system component responsible for rejecting system heat. Condenser reject both latent and sensible heat. Water-cooled condenser are more efficient than air-cooled condenser. There are three types of water-cooled condenser. It is tube within a tube, shell and coil, and the shell and tube. Mineral deposits in the water circuits reduce the heat transfer rate between the water and the refrigerant. For advantages of water-cooled condenser, it has high thermal conductivity of water. It has high specific heat water. Water-cooled condenser has less flow rate required, high heat transfer coefficient, and high coefficient of performance. For disadvantages of water-cooled condenser, it has large installation and maintenance costs. The pump is required for water circulation. It has large energy consumption. Last but not least is evaporative condenser. Evaporative condenser reject heat into the atmosphere by spraying the coil with vapor. Some heat is transferred to both water and air, which increases the ability of the condenser. Evaporative condenser can be mounted both indoors or outdoors by using ductwork to discharge the exhaust air outside. For operation of evaporative condenser, the evaporation of some provides the cooling effect, thereby steam condenses. Steam to be condensed is passed through grill tubes and cooling water is sprayed over outer surface of tubes. The evaporative condenser are most suitable for small plants where supply of cool water is limited. For the advantages of evaporative condenser, it has simple in design and low initial cost. Low quantity cooling water required in evaporative condenser. Small capacity cooling water pump and low operation cost. For the disadvantages of evaporative condenser, vacuum maintain is less. Due to less vacuum, work done per kg of steam is less. Evaporative condenser is not suitable for medium and large power plant. That's all from me. I will pass the next slide to the next candidates. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ismail Najmi Beruzi. So I want to present about material device. So material device is a part that dramatically decrease the temperature and pressure of the refrigerant coming from the condenser until the refrigerant reach the evap. Second point, material device can be as simple as the capillary tube, which are two full long spiral of copper tubing that is the capillary tube is commonly used as a system metering device because of its simplicity and low cost. Next, the thermal expansion valve or TSV are the same means metering device for the other language. Is a more kind of metering system. There is a sensory valve. So in a metering device, they have sensory valve in a metering device at the top of the TSV. That is connected to the suction line. There is a fluid in the sensing bulb. The drop in the temperature and pressure in the sensing bulb is converted into the drop and pressure in TSV and the release tension. For how it works, air conditioning use a circuit that is closed, repeating itself. So for the refrigeration, it be recycled. And next, the metering system is responsible for feeding the evaporating coil and the proper amount of refrigerant. A high temperature, high pressure subcooled liquid exists in the device as a low temperature, low pressure saturated liquid is the refrigerant entry the metering device. Okay, we have three the type of especially for daily use. One, the capillary tube. The capillary tube is fixed for device, mean that there is no change in size in the opening the refrigerant flow through. On critical charge structure, capillary tube are located. There is an exact amount of refrigerant in critically charged system and all the refrigerant pass through the system at all times.
Hello everyone, my name is Kishan Rachanaliki Ganesh from 3BMMH 1/2, matrix number B091810-319. Today I am going to talk about evaporator. What is an evaporator? An evaporator is a heat exchanging device in a process where liquid form of a chemical substance, for example water, will be changed into gases or vapor form. Okay, there are a lot of applications of evaporators. They are majorly used in pharmaceuticals, food and beverage industries, chemical industries, any heating, ventilating and air conditioning system, and a lot more. Next, I'm going to talk about working principle. Okay, first, after the refrigerant exits the metering device, the pressure drops to an appropriate saturated pressure and temperature that is low enough to pick up heat from the air passing around it. Next, the heat from surrounding air will be absorbed into the refrigerant as it boils, causing the refrigerant liquid to be evaporated into vapor. The surrounding space will be cooled at the same time. Next, the saturated vapor refrigerant then again will be routed back to the compressor and continue the refrigeration cycle. Okay, next I'm going to talk about the types of evaporator. I'm going to focus more on construction based evaporators. Okay, first there is bare tube evaporator. Bare tube evaporator are made up of copper tube or steel pipe, where copper tube used for small evaporators where non-ammonia refrigerant is being used, while steel pipe are majorly used for large evaporators where ammonia based refrigerant is used. They are usually used in liquid chilling. Next, there is plate type evaporator. Plate type evaporator, it have coil made up of copper or aluminium where it is fixed on the plate to form a flat surface, and this type of evaporator are widely used in domestic refrigeration. Next, there is fin evaporator. Fin evaporator actually is a bare tube type, but it is covered with fins in order to increase heat transfer capability of the evaporator. It is more effective than bare tube evaporator. This type of evaporator are commonly used in almost all types of air conditioners. Then there is shell and tube evaporator. These evaporators are used in large refrigeration and air conditioning system or on central air conditioning system. This evaporator consists of large numbers of tubes inserted inside drum or shell. Depends on direction of flow. They are classified into two types, which is dry expansion type and flooded type. The last one is shell and coil evaporator. Shell and coil evaporator have one or more spiral-shaped bare tube coils fixed in the welded steel shell. It is generally they are expansion type with in the coil the refrigerant located in the coil while cool liquid are in the shell. These evaporators are used for chilling of drinking water and other aspects where cleanliness is an factor. Thank you very much. That's all for today.